Chapter 6 review number 12. What we have is similar figures, okay, from that similarity statement. So we know corresponding angles are congruent. In similar figures. Okay, we also know that corresponding sides are proportional. Or have the same ratio. That's what that means too. So this problem is about what's the measure of angle N. So if you look, they give us angle C, the measure of angle C, which is right there in the third position. N is in the third position, so they're trying to get us to use this concept. They're corresponding angles, same position, and so they must be congruent. All right, so the measure of angle C without any work is 40. Okay, so we have segment PR is 21, and we have a partition segment. So Q is going to partition the segment in a 4:3 ratio. So let's say that it goes 4:3, a little more than halfway. We're trying to figure out how to split up the 21. 21 is actually the whole way. Now, what I usually use with 4:3 ratio is I tend to use that there's 7 equal parts. Whenever I do these partition questions, 7 equal parts. So what's in each of those parts? So what I do is I take 21 divided by 7 to get 3. So that tells me 3 each. So 4 of those 3's is 12. 3 of those 3's is 9. Notice 12 and 9 add up to 21. So there's 12 and 9. 12 from here to here. So what's the length of the longer segment? We got 12. Okay. All right, those are parallel. F, G, D, E, B, C. AB, the whole thing, is 48, 15, 20, and 25. Okay. So find these other lengths. Okay, the connection here is the 48. A little odd. Let's call these X, Y, and Z. Here's what we know. It's that. What we like to call the side splitter theorem. I know that's just what we call it. So basically, here's how it goes. When the segments are parallel, they split the sides into proportional parts. So that's essentially our side splitter theorem. Okay, we're just trying to show you that X is proportional to 15, Y is proportional to 20. So we're going to use that, but we don't have any connection here until we saw the 48. Okay, so the 48's that whole side. What we want to do is we're going to have to add up those. So 20 plus 25 plus 15 is 60. So the ratio we can use, if we put these on top the whole time, is we've got 48 to 60. Then we can start breaking apart these. X equals X over 15. Use cross products. Okay, 60X equals 720. And that's 12. Okay, so X is 12, so that's AF. Just going to put this over here, keep track of them. AF is going to be 12. 20. People do use scaling up, scaling down, but I'm just going to keep going with proportions. So 60y is, I think that's 960. I'll check in a second. Let's say that's 16, but let me double check that. Yeah, okay. So then we had y, which was FD. Yeah, we gotta define B now. Let's use 48 to 60 equals z over 25. Cross products, 60 times z, 48 times 25. 1200 divided by 60, and we get 20. Looks like 20, okay. So then that's dB, right? Is that what they wanted? dB. So dB is 20, and that's all of them. So we've got another one to do here. All right, the two triangles below can be proven similar. Which triangle similarity postulate is the most direct method for proof? Well, they haven't given us any angles, so it's probably not this one or that one. Angle bisector theorem, that's not what we do. To prove triangles similar, let's check proportional sides. Now, how do you know which ones are corresponding? Well, the 6 is the smallest on this triangle. The 15 is the smallest there. It's got to be what matches. We'll box in these. Maybe take our highlighter and highlight that pair. So now you know which ones are corresponding. So 6 is to, we'll keep these on top all the time. So 6 is to 15. As pick another one. 7 is to 17.5. Okay, cross products, 15 times 7. 6 times 17.5. It's kind of a question mark, actually. Are these equal? We're kind of finding out. That's 105. And 42. Yes, so is that. So what happens is that's a true proportion, which gives us 2 of the s's, essentially. Those pairs of corresponding sides are proportional, so we at least have 2 s's. We need a third, though. So let's just stick with 6 and 15. But now let's go grab 8 and 20. Now again, it's a question mark. We're trying to find out. Use cross products, 6 times 20 and 15 times 8. Now they do both become 120. Since that is true, that's our third S, the pair of corresponding sides that are proportional. So there it is, side, side, side. So let's do one more here. So 610 is A prime, and the center of dilation. The way I do these is I just take one direction at a time. The change in x from the origin to A, that is 6. So we're talking about this distance right here. Now, for the change in x for O to A prime is only 3. So what I try to do right there, I should be able to solve it right now. The scale factor is the distance from the image to the center over the distance from the pre-image to the center. Now the image is the new, that's 3. The pre-image is the original, so we can reduce that to 1/2. I'll show you how. Again. So how we reduce is it's 3 times 1 and 3 times 2, and the 3's knock out. So the scale factor is going to be 1/2. Now we're going to need to apply that to the same, okay, so b is negative 2, 4. Wait a minute. This is b prime. All right, so this is backwards. So the scale factor is 1/2. So how do we work backwards? How do we get the original for b? Well, basically we're going to multiply by 2. That's the reverse of dividing by 1/2. Or that's the same as dividing by 1/2. It's the reverse of multiplying by 1/2. So we're going to multiply by 2. The change in x, now remember from O to B prime is going to be 2. So the change in x from O to B needs to be 2 times 2, which is 4. All right, so I'm going to go 4. Do the same thing for y. Change in y for O to B. So you got to go up 8. And that should be b. That's the coordinates -4, 8. There it is. Okay. Yeah, we'll do this on the next video.